Hello guys, welcome to the back to the channel. Today we are going to solve problem number 22, generate parenthesis. So basically what you're given here is n, and then for that n I need to generate all possible combination for that particular n. So here n is 3, so all possible combination is 1, 2, 3, 4, 5. So 5 possible combination present of well-formed parenthesis. And then when n is 1, then definitely there is only one possible combination. And let's say n is 2, then how many possible we can have? So maybe like this, 1 2 opening, 2 closing. So this is one possible combination, and then second could be 1 opening, closing, opening, closing. So this could be another possible combination. Anything else possible? No, right? I think this is the only subset can be formed when n is 2. So likewise this we need to tell what are the all possible combinations when for a given n. So first of all, how do we solve this problem, right? So in traditionally in LeetCode, when you see permutation, combination, these kind of words, right, typically it is done by backtracking. So you have to backtrack the problem starting with the empty substring, and then you start generating possible combination. But we cannot randomly generate possible combination, because this could be also one of the possible combination, right? But this is not actually value substring. So we have to generate in a such a way that we always have the value substring as part of the our final result. So one thing we show, right? So when we say that n is 3, right? So that means we can observe that there will be only 3 opening brackets and 3 closing brackets. I cannot have 4 opening brackets or n greater than 3 or closing brackets. So definitely I need closing brackets and opening bracket number should be same, right? And we also need to know that as long as you have opening bracket, your closing bracket should be either less than or should be equal to the opening bracket. If I cannot have 4 opening brackets here, closing brackets here, right? In this case here. Alright, so let's try to think, dig more in this problem, and then we go ahead with the solution. We'll talk about the solution later in the video. So what we have to do is, for example, and let's try to solve with the n equals to 2. So we know that this will be solved by backtracking. So we start with empty substring where there is how many possibility we'll have. So with the empty substring, I can have opening bracket or I can have a closing bracket, correct? Oh, sorry, not the a closing bracket. But with the closing bracket without any opening bracket will not lead to any valid parenthesis. Definitely any criteria when I'm pushing any opening or closing bracket, that has to be either opening bracket should be equals to n equals to 2, or it should be less than 2, right? And then same goes for closing bracket. So closing bracket cannot be greater than the number of opening bracket I have right now, and it cannot be greater than as well 2. That's the limit, right? So for n equals to 2, I have this one possible combination, and then this one is another possible combination, correct? Now starting from this point, so I can go further down in the tree. So here again I have 2 possible combination. Either I can add opening bracket or I can add closing bracket. Can I add opening bracket? Yes, because still I'll have only 2 opening bracket as the result here. And then can I add closing bracket? Yes, right? Because then still it will be a valid parenthesis, because already I had 1 here, and then when I add opening bracket, closing bracket, that still will be less than count of this, and then this closing bracket will be less than 2. So that's one possible. Now if I go further down in the tree, again this will have 2 state, one where I'll pass in opening and one where I'm going to pass closing. Can I add furthermore opening bracket here? No, right? Because if I add 3 bracket, then that will violate my condition, because I cannot go beyond n equals to 2. But can I add closing bracket? Yes, right? I can add closing bracket, so that's going to be, and then yeah, yes, it is still valid, because again if I further go down, I can add another bracket, but I cannot definitely add opening bracket. If I add the opening bracket, so that will violate my conditions, but I can still add closing bracket, because this opening bracket is actually going to be greater than 3, right? And then can I add closing bracket? Yes. So this is one, so this is what I'll get at this end. So this is one of the result I got, a value parenthesis. Now I cannot go further down, because I'll hit I'll hit the base condition where n is positive. Same thing, I can go ahead and can draw this one. I'll add opening and closing. Opening and closing. Can I add opening? Yes. Sorry. This is the one, right? Can I add closing? No, right? Because if I add closing, then it will become greater than the opening bracket. So that will, I'll not have a valid parenthesis. Then further down, if I go here, so this will actually give me this like this. So this is another valid state I'll get. Now I cannot go further down in the tree. So this is my tree. So I kind of find this path here, where I go from here, and this is one of the value parenthesis I'll get, and if I go from here, so this is where I'll get another value parenthesis. So this is a tree and overall explanation of the problem. So first step is to identify what kind of algorithm you need, whether it's a dynamic programming or it's a divide and conquer or combination. Then once we identify it is a backtracking problem, then we can start with the empty approach based on condition, and then we can keep drawing the tree and then reach to the final state. So let's try to solve this problem. So I'm gonna need is the result, where I'm gonna basically keep all the info, all the valid parentheses, and then at the end I'm going to return that one, right? I'm also going to need a helper function for backtracking. So what is going to be input is basically the number of opening and closing bracket count, because that's based on that I'm going to take decision. And what is the base condition here? So base condition is definitely when open bracket and close bracket is actually equals to n. That's where I'm going to have base condition, and then I'm going to append all the, so I'm going to also use that for keep track of these incoming brackets. And then as soon as I hit this condition, and then I'm going to just join the results of the stack and then put it back in the result, put it back in the result set. Let's say I call it result.append. And then I just return from here, nothing to return from here. Okay, now comes where I need to check whether I start with the open bracket first, right? Definitely initially I cannot start with the closed bracket, and then that open bracket has to be less than n, and then in the stack I'm going to append the open bracket. And then again I'm going to do is backtrack. So backtrack, since I had appended the open brackets, I'm gonna do +1, and then close doesn't increment here. Since I'm using single stack, so I need to pop it out the last operation, last element. Second thing, now this is for open, so now second for is a close. So close has to be actually, again same goes for close, it has to be less than open. Then I'm going to append it to the closing bracketing, and then again I do the backtracking helper. So this time I have appended the closing bracket, so I'm going to increment the close +1, and then same as I'm just going to pop out the last element for the further operation. So I think, yeah, this is all code. Just we need to call the starting from 0. So since it is 0, so 0, 1, 2, so always be less than n. Okay. And yeah, let's try to run and see if this works. Yeah, so test cases pass. So let's try to submit. Yep. So it is accepted. So thank you. That's all for today, and thank you for watching. See you in the next video.